Good morning, everyone. Welcome to Purdava session. We are into multi-threading, and in previous session we have seen some topic, right? How to create the thread by using extend keyword and by implementing runnable interface. The two approach we have seen, and the best approach is runnable interface. We have understand why, because runnable, by implementing runnable, we are able to achieve inheritance also, because we can extend one more class, right? But if we extend only thread class, then we cannot extend other class, right? So this is the good approach, runnable interface. Okay, we have seen yesterday in previous session. We have seen about this t.start method, t.run method. Okay, now we have seen the life cycle also. Okay, now we will see some program also. Try to observe. The program related to what? Runnable interface. ठीक है? Runnable interface. ठीक है? What is runnable interface? You can achieve the multi-threading concept using what? Runnable interface. ठीक है? Now try to understand with the programmatic approach and the some use cases for this program. ठीक है? Now this is, let's say this is test class. Already it is implement runnable. Okay, this is a run method. Guys, this is run method, right? This is run method. So whenever we are writing this code, implementing runnable, means we are defining a thread. And whatever inside the run method, whatever we are going to define, that is nothing but a job of a thread. Thread is nothing but a code. So we are using some for loop, just which thread will run, which thread will not run. If I will use one sysout statement, it is not going to help you understand which is sysout statement get priority. Okay, that's why I'm using what? For loop. So that some loop will be run 2 to 5 times, right? Whatever the loops we are giving, based on that, we will understand the what output is, which thread is running, main thread or child thread. Okay. So inside job, inside run method, whatever we are defining, that is nothing but what? Job, and we can call as child thread. System dot out dot system.out.println. So this is nothing but child thread, guys. Child thread. Try to observe. Child thread. See, this is very easy topic if you focus. If you won't focus, then you will find it difficult. Okay. For loop I am copying. Okay. Now try to observe. I am keeping here loop. I am giving this, let's say, main thread, child thread, main thread. Try to observe. Try to observe. If there is a two class I am using, then this is called defining a thread. I am defining a thread now. I am making test class as a thread class. So this is nothing but defining a thread. Okay? Now, this is run method. This is run method, right? This is run method. This is run method. Inside run method, I am giving some task now. That run method, do this thing, do this thing. This is nothing but a job. This is nothing but a job. Job of a thread. Okay? Always remember. We very much important whenever we are working with thread concept. Start method, run method. Start method is the heart of threading. Start method internally calling run method. We have seen in first session. Always remember, keep in this mind. Based on that, we are going to discuss today use cases and understanding. Okay. So now what we have done in this line number 3, we have defined a thread by implementing runnable. Okay. Now we have defined thread, we have defined job. Hey run method, do this job. Right? In now, in runnable interface don't have run method, guys. Keep in your mind, there are two approach: extend thread or implement runnable. Extend thread and implement runnable. Thread class, if I am using this line, let me copy this, paste here again, comment this. If I am using extend thread, but I am using extends thread class, extend thread class, spelling mistake, extend thread class. In this thread class, run method is there. Are you getting? In this thread class, run method is there. We are overriding it. But in runnable, there is no thread class. Sorry, there is no run method. Till now, you are good, right? So there is a challenge when we are using thread, and when I am doing what? T dot start. When I am doing T dot start, see T dot start is coming, right? When I am using this line, extend thread, T dot start, when I am doing it is calling internal run method. Okay, we are overriding, so it will come. If I don't come, I don't run this, I comment this code, then run method will run from thread class, which is having no implementation. I will tell you diagrammatically, guys. Try to observe. Then you will understand. Try to understand first. This is a thread class. Okay, there is a run method. There is a run method, but there is no logic. Right? So what we are doing overriding. Right? We are writing our logic. So this T start method going to call what? Run method. First of all, run method. Right? But now I have commented now. I have commented this part. So run method, internal run method will be called. So no output. No output will be there. But the moment I will uncomment this is going to call. Try to observe. Let me uncomment this. Let me uncomment this. Control question mark. Save this. Now tell me what is going to happen when I am using T dot start. When I am using T dot start, right? When I am using what? T dot start. T dot start method internal call run method now. But now run method is available here, right? Run method is available. It will look for its run method. We have implemented. So this is going to call. Some output we are having, right? When we are using thread, but when we are using runnable, we don't have. Now I will uncomment line number 4 and comment line number 3. Try to observe. Try to observe. Okay. I am commenting this thread class, and I am uncommenting this implement runnable. See, when I am doing implement runnable, see error is there, right? T dot start. There is no start method. There is no start method in runnable, but still we can achieve thread. We can define test class as runnable, right? So now the problem is how I can start my thread, because without that we cannot run, right? So we need to define a thread class. We need to define a thread class. Okay. So how we can define a thread class? Simple. Create an object of thread class. New thread. We are doing implementation, but what we are doing? We are defining a thread. Now we are creating a thread object. Do you think there is relation between this test class and thread class? Till now, there is no relation. There is no relation. How I can establish this? How I can ask this thread? Hey, thread, just look for this my test class. I defined that already. So I have to pass this test here. It all control shift tab. Try to observe. I am passing this test class. Where I define this test class as a thread here. How I define? By implementing runnable. But there is no start method now. There is no start method. So that's why I need to create thread class object. Thread class object has the start method. So I am giving this test to this thread class. What is this mean by this two line number 14 and 16? See, By this line number 4, I created a bike. I created a bike, but there is no driver. Then who will run the bike? Who will run the bike? So I need a driver, na? So this is a thread class object I created. I hired one driver. Hey driver, I need a bike. I have a bike, but how to run? Who I want to ask that, hey bike, hey driver, go to my bike and drive. So how we can configure pass this object into this test. Now relation established, then this driver will run the bike. Which bike he will come to, right? The same way we have created thread class, but we are passing this test class object so that he will come to know that he has to run something. Now we will run the program. What happened? What happened? For loop is there. Okay. I did not started na. I did not started. T dot start I need to do. T dot start. I told you, right? T dot start is the heart of the. Now only when without T dot start, only this was running. Was this running? Any output with child? No, right? T dot start method is going to call internally what? Internally it is going to call run method. If we are defining run method, it will call this. If you don't define our run method, then it will call run method in thread class, which has no implementation. If I don't have this run method, still we are not getting to, but in background, one method is there. That is run method. See, asking runnable interface is having one method, run method. It is asking add unimplemented method, nothing but runnable.run. So we are defining this. So run method override. Now, if I run this program, main method run, child method run, main method run, something. We don't know the order. We don't know the order, which thread will going to run. Right? Always when we are defining one main method, there is one main thread. Okay, now we are defining our own thread. Inside this main method, this is the one main thread output is going to print. And this is our thread. So which thread? There are two threads in this scenario. One is my main thread and one is our own thread. So which output will come? We don't know. See, sometime main method, sometime child method. Sometime main method, sometime child method. That is how we can define priority. Priority means which one should run first, which one should run second. That we will see in setting the priority of the thread. But in how many threads are there? Two threads, one main thread. I am not talking about main method. Main method doesn't mean main thread. Whenever we are calling main method means one main thread is going to run in background. Because of which this output is coming. In this 3 line, what we are doing in this test, in this line, implement runnable, we are defining the thread. We are defining the thread, right? By implementing runnable. Here, in this line, what we are doing, we are inside this for loop, right? We are defining a job of a thread, right? Job of a thread. In this line, what we are doing, we are defining our own thread, asking to run our job. Hope we are good. Hope we are good. But which one run first? We don't know. If I will run again, the output will vary. Main child, something will be different. See this? Now this is main, or everything main run, now child. If again I will run the same program, which thread will run? We don't know. Now main, right? Let me run again. Now see, child run main, then child, then main, right? What output will come, we don't know, right? So this is the behavior. Now we will need to see, understand the use case. Now try to observe the use case different. We cannot expect the output in this situation. Now it is your duty to remember the thing. Thread class, try to understand. Try to understand in simple way. Runnable has what? Run method. Thread class have start method, right? If you are implementing runnable don't have start method. So we have to create thread class object to start this. Then the start method will call this run method in simple way. In simple way. This you have to keep in your mind, right? ठीक है, ठीक है, ठीक है. चलो आगे. Now let's now if we have different use case, what will be the possible use case? Try to observe. Already we have created object of our class. If we have one thread, can we define one more thread? We can have one more thread also, right? Two thread, five thread, right? Try to observe. Copy this, paste here. Can I remove this test and test here? Let me give it T1 and let me give it T2. Now there are how many threads, guys? T dot start is not possible because I need to establish the relation. I need to pass this test object here. Then only this T will run. Sorry. Now try to observe. Let me come. Okay. Now now try to observe. Some small twist we are going to do. Everything is there. Only just we created two thread. I did not establish the relation between this our defined thread and this thread class. Let me pass this variable. Now there are two threads. Try to observe, guys. There are two threads. There are two threads. Thread 1 and thread 2 object. In thread 2, I am giving the run. Now try to observe. What is the output is coming, guys? What is the output is coming? Right? Only main. Run this. Main only, right? Main thread. Okay? Run this again. Only main is coming, right? Main is running, right? Main is running. Why? Because understand here. Understand the situation. Understand the situation. I'm creating one more diagram here. This is one thread and this is one thread. Okay. In this thread, did I link this test? Did I link this test to this T1? No, but I link this test to T2. But to run the thread, start method is required to call, na? Start method is required to call. I am using T1 dot start. T1 dot start. But do you think any relation is there between test and T1? No. Start method internally going to call what? Run method. This is our objective, right? Main common sense. So that's why only why output main is coming. Because see, T1 dot start is calling run method. T1 dot start is calling method, but there is no relation between test and T1. So that's why this is not printing. There is no relation between this. Because inside test class, we have defined run method, which is going to print what? Which is going to print child. This is the job of this, right? Did we create any relation between test and T1? Any test and T1, any relation is there? No relation is there, right? No relation is there. But where is the relation? Test class and what? Thread 2. Because I am passing test class here. But I am starting the start method. But which variable is there? T1 there. T2 is there? No. Only what? T1 is there. T1 is going to start the method. Fine. T1 is going to start the method. Start method is going to run method. But this run method is belonging to whom? This run method is belonging to what? default thread class, which has no implementation. That's why no output is coming from that thread, run object, run method. Only main is coming. The moment I will change here, the moment I will change here T1 dot start to T2 dot start, we will get output. This is one thing. Or I will pass this test here, then also the output will come. Now we will see these two cases. What will happen? Try to understand. The first is either I have to pass this test, either I have to pass this test here, or either I need to make T1 to T2. Hope you are observing this diagram. I need to establish the relation. Now, try to understand. First I will pass this test here. So that relation will be established now. Now T1, no, okay, test is the one. I have to take care of that. Inside the test, we have run method. Okay, now run this program. See, main and child both run, right? In which order? We don't know. But main method also run, main thread also run, but child thread also run. We have established the relation now. Now, remove this test from here. Fine. And make it T2. Now in this thread, there is no relation, but it is going to. Now this thread 2 is no, there is a relation, test and this test class. And this T2 thread is going to start T2 dot start. Try to observe. Run this program. Still we are going to get the output. In which order? We don't know, but we are going to run two output. One is from main thread and one is from child thread. Hope you are good with this explanation. We are going to use T1 dot start, T2 dot start. That is fine. Hope you are good with this explanation. Now try to understand. Always guys, we require start method. Start method only can run the method, run the output. Without this start method, no thread concept is there. Try to observe. Can I call this T1 dot? Can I call this run method directly? Another use case. T1 dot run method. T1 dot run method. Let me run this program. Only main method is coming. Main thread is running. Even though I am calling T1 dot run, any output is coming? No. Because there is no relation between test and this T1. And I am calling T1 dot run. No output is coming, right? No output is coming. T2. Okay? Can I make it T2 dot run? Let me run T2 dot run. I am using T2 dot run. Now try to observe. In this method, both main and child. But T2 dot run is like a normal method, guys, not a thread. It is called, we are calling this thread. See, output will come child and then main method. Child and main method. Try to run child main method. 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 It means this is called T2 dot run. Right? There is no start method. There is no start method calling run method. So there is no thread. It is just like a normal method call. When we are not having start method means there is no multi-threading concept. We are not using thread concept. This is running because main one thread is running. That is main thread. Main thread is calling this program. But when we are using direct run method is called, but it is treating it as a like a normal method, not a thread job. Because start method is going to run method. Do we have start method here? No. We have commented this line. Output is coming, but don't get confused. Child method is main method is running, means thread is coming. In this program, we are creating three threads. one thread, second thread, and main thread. But output is coming from main thread, not from child thread, because other thread 1, thread 2 not calling start method. To run this program, we always require what? Start method. Hope you are good. So we have defined how many use cases we have discussed when we are calling from T1 dot start, when we are calling T1 dot run. This is one use case we discussed. Then we are using T1 dot start, T1 dot T2 dot start, T2 dot start. Then T2 dot run. These 4 use cases we have discussed, right? When you are writing the code, you are playing with then you will understand. Okay, then you will having more practical understanding how it is running. Okay, how to format, select all, control shift. Till now you are good, right? No. No. So T1 and T2 what? It is thread class object, right? Can we call from test class dot run method? Test class dot run method? Yes, we can call it. Can we call test from test class start object? No, there is a compile time error, right? It's a compile time error. So we cannot use start method because there is no method runnable. See, test is implementing runnable now, but there is no start method in runnable. Start method is available in what? Thread class. So T1 dot T2 can call start method, but not child of runnable. Who is the child of runnable? Test. But if it is you are using this class test extend thread, then you can call in that way. Let me comment this line and let me uncomment this line. Now test class object is created now. Now see, no error, right? Test dot run is fine because test dot run. Who is the parent of test class? This time thread. Thread have the run method, but not in runnable, right? Let me uncomment this. When I am using this, now try to observe test class having issue. Hope you are good. When I am using test dot run, why no error? Because test is looking run of the run method as a normal method. So method calling is happening. So that's why no error. Hope you are good. These are call now. That's why it is giving output. It will come in this line. Test dot run. So test dot run. Always this treating as a normal method. All file loop will be done. All child is printed. One done. This line is logic done. Then this loop will run. So always your output will be fixed. Child, then only main. There is no other our thread because test dot run is going to call what? Our method. Hope you are understanding this concept, guys. Hope you are understanding. These are very important. Very important concept. Okay. Now, yesterday we have seen some more concept, right? Okay, that is gone. Maybe I did not written right here. Yeah. Yesterday we have seen thread class constructor also. In you can watch that recording. So you will find we have used thread class constructors. Different thread class constructor. Yesterday we have seen and setting or name of a thread. We have defined using set method and get method. Yesterday we have seen this. Yesterday only these two topics we have seen, and whatever I am explaining these use cases today we are taking. Okay. If you watch yesterday recording, you will come to know how many constructors are there, how to get and set the name of a thread. Now, if we are defining a thread, then we are running output. Sometimes child is running, sometimes main is running, sometimes child thread is running, sometimes main thread is running. We don't have control on that. Na? What is the output? That whatever the output will come, we don't know what output will come. What output will come? We don't have control over it, right? Okay? So that is something we don't know the priority. So now we can define the priority of a thread. So now our topic is what? Priority of a thread. Thread priority. Guys, don't get confused. We will see how this threading is the concept is used, right? Some use case we will define. Just remember this one concept in your mind. Then I will create one program there. You will understand this multi-threading concept. Just for now, one concept is there. Then you have to think about all the concept in your brain, and then we will prepare one program at end of this enhancement of the thread topic. Okay, now, so thread priority. What is this thread priority? Every thread, whatever main thread we create, every thread has its own priority. Every thread has some priority. Priority means you have priority. What is your priority now? Pass out to get a job, right? In your call, if you are learning your call, what is your priority to pass semester exams? Okay. If you are in 12th standard, what is your priority to score a good score in 12th standard? This is the priority now. Priority means something in order, which is there are 10 tasks, but first which we will complete, that is some having more priority, right? Okay. Now, if thread in Java has some priority, okay. Okay. Thread is the range of thread. The range of thread is from 1 to 10. 1 to 10. Okay. 1 is the least priority, 1 is the least priority, and 10 is highest priority. Okay. Okay. In thread class, come here, Control Shift H, thread, open this, already open, double click. Okay. Copy this, find this, dot min. 1 second, right? Now see, right? These are the variable. Minimum priority, normal priority, maximum priority. Okay. This normal priority is from main thread. Main thread means main thread whenever running, its priority is 5. It is not less, it is not high, it is minimum average priority. Default priority assigned to thread is 5. Minimum priority value is 1. How we can call this minimum priority? Class, this static variable, na? Class name dot variable name. So how we can call this priority? Thread dot, copy this, paste here. When we are calling, what this value indicate? 1. When I am calling thread dot max priority, when I am calling this variable, what is this value? 10. Right? These are defined by Java people, not by us. Okay, there is one normal priority. Copy this, come here, paste here, thread class dot variable name. Normal, this mean the priority is 5. Okay, there is, okay, hope you are good. Hope you are understanding. This number we are going to use. Okay. Now, who will get this number? Thread scheduler this number. Thread scheduler is going to use this number. Thread scheduler, scheduler, scheduler. Use this priority number. Priority number. Okay. Priority number. Allocate to use this thread in CPU. Okay. Now, what does this mean by thread priority? The thread having highest priority will get output first. Highest priority will get chance for execution. Execution first. Least priority will get least chance for execution. Hope you are good. Now, priority means default priority. Let's see with the help of a program. Come here in our program. Okay. Already we have defined one thread, right? This is our test class. Let me use this. Instead of this, let me use this. Okay. What I'm using? Class test extend thread. Okay, that is fine. We have one job defined inside this. Okay. Let me delete this thing. Control D. Okay. Simple program. Okay, simple program. I'm comment. Let me delete this also. Clean the code. How I can clean the code? Okay. Now, I am not keeping anything for now. Comment this line. Okay. I am commenting this line also. What is there in our code? Test extend thread and main method. Simple object. Now let me print the thread. System.out.println. System.out.println. Let me print the thread. There is no thread created. So only main method we should going to run with the help of main thread. Let me test the priority of the main thread. Thread dot current thread. Current thread dot get priority. Get priority. What should be the output, guys? Did I use anywhere this thread object? Right? This is extend thread, right? Now let me check what is the priority of main thread. Let me run this program. You will get the output 5, right? Which is defining our statement, right? Normal thread means 5. Main method is always having the priority 5. We are justifying, right? Now, next program. Let me uncomment this line. Now I am defining a job, right? I will create one more thread here. This is the perfect example. Now, I have created this. Okay. Let me uncomment this line also. Okay. Let me delete this now. Now try to observe. Now try to see. This is our test class, right? Normally, right? Now, let me do this priority. Can I say change the priority of this thread test and then start the run of let me test dot start method. Now try to observe, guys. Focus. Now very important. Try to observe. Simple program. Test class extend thread class means start method available na. Normal, this is normal program. Now I am going to change the priority. First, let me run normally. It will any random will going to run. Child, main, child, main, right? Main, child. If I will define the thread priority, I will define this test thread. I will define you the priority. I am giving it the list. I am giving the priority. Let me test dot set priority. See, there is a priority, right? Method. It is going to take some number, max or mean or something. I am giving to number. I am giving some number that is 10. Highest priority I am giving. Highest priority I am giving. It means child thread is going to run always first. Child thread is going to run first. Observe. Because I am giving thread. See, my main is coming. Set t dot start. 1 minute, 1 minute. Let me check what is wrong with my program. Class, test, extend thread, public void run is fine. Child thread is there. Then main method is there. Okay, this is perfectly fine. Okay, I am giving this priority as 10. Okay, now t dot start. Set the priority 10. Now run the program. What you are getting, guys, always? What you are getting always? Always child, right? Always child. Because I have given more priority to our child thread. Now I will run and comment this line. Now try to observe. Run this program. See, main child. Some random output is coming, right? We don't know what is going to run, right? Okay. Hope you are getting the output, right? Now order is changed. Only one line, this line. I am setting the priority. Means I am giving the priority. Okay. When I will give the list priority means one, this will be the run last, right? Run. Now, what is run first? All main. Because of this, this will be run by main thread. So this will be run first. And I am giving less priority to our thread. So all output will be run our after main thread. So child is coming last. Child is coming right last. Right? You understand the thread priority, right? Till now? Okay. So guys, please practice on this program. Watch the recording if you don't have time. Watch this recording, see the program and practice this. Okay? Very, very important. Tomorrow what we are going to say, how to stop the thread execution using yield, join and slip method. And some more topic. Okay? Please practice this. I am stopping my screen share. I am stopping the recording. If you have any doubt, let me know.